there, scientists. Welcome to Room 9, our region's largest classroom. I am so happy you're here with me today to learn more about the world around you. My name is Mrs. Newby, and I teach at Flint Park Elementary School, which is in the school district of University City. Today, I'm going to be teaching science for first grade, but as always, everyone is welcome to learn with us today, and I'm so excited to get started. So what we're going to be focusing on today is actually more about patterns that we notice in the sky and how are we even getting these patterns. So last week we talked about how we get day and night. Today we're going to talk about what kind of pattern day and night is, and also we're going to learn how we even are able to get seasons. You know those 4 seasons we get throughout the year? My favorite is summer, but I'm sure some of you guys love winter or fall, where the leaves just change colors and the trees look so pretty. Or even spring, when those pretty flowers start to bloom back again. Well, we're going to learn how we even get those. So let's get started. And the first thing I want to ask you is, what do you think a pattern is? Now, I can probably think of a pattern that I can maybe draw on here. And while I'm doing that, I want you to make a pattern on your paper if you have one near you. What kind of pattern do you think you can make? I'm going to use orange, and I'm going to make a pattern with colors. Orange and purple, because I love purple. Okay, I'm going to do a circle. Then another circle. I'm going to do 2 orange. And then purple. If this is how I want my pattern to be, what do you think would be the next one after this? Would it be another purple? No, because there's only 1 purple here. So I'm going to make it repeat. Orange, orange. What would go next? Let me color these in so you can see it better. Yeah. The next thing that would go is another purple one. That's so cool. I just made a pattern with colors. Purple, orange, orange, purple, orange, orange, purple. And if I look closely, the ones that are constantly repeating over and over again are the purple, orange, orange. That is starting over here, and then it's going to start over here, but I kind of ran out of space, but we know that if the paper continues, it's going to be orange, orange. So this is what a pattern is, and when you see patterns like this, you start to see them kind of cycle. So then they start becoming a cycle because the pattern keeps repeating over and over again. And guess what? We get cycles in our world, and we get to see them in the sky, and we're going to find out how. So last week we talked about the word rotate. We know that if we live right here, the earth, now we're going to talk about this a little bit more today, is actually tilted. So it's not like straight up and down, it's tilted. But the way that we get day and night is because it rotates. So it just kind of rotates in its place like this. But actually it doesn't rotate in its place. We're going to talk about what else it does. So my thinking also is, well, how long does it take for this star, which is us, to go from here all the way back here? Does it go super fast like this? Are we spinning super fast and rotating super fast like this? Or does it go super slow? Well, we're going to find that out, and we're also going to find out why in the world do we have a tilted earth, and what does that do for us? So I read some of these pages last week, and I want to read 2 more today. from Earth and the Sun by Bobbie Kalman, and this is from Crabtree Publishing. So this is a nonfiction book, and like I said before, we don't usually read nonfiction books from front to back. If we want specific information, we just look at the pages to give us that information we're looking for. So we're trying to look for how long does day and night happen, and also why do we have a tilted Earth? So in the table of contents, I already found one that says day and night. I'm pretty sure that page is going to give me the answers I need, so let's check it out. So let's go to page 8, and the title up there says day and night. As Earth travels around the sun, it slowly turns in circles. It takes 1 day for Earth to turn in a full circle. That's interesting. For about half of the day, the part of Earth where you live faces the sun. When Earth faces the sun, it is daylight in your part of the world. For the other half of the day, the part of the Earth where you live faces away from the sun. When Earth faces away from the sun, it is nighttime in your part of the world. That is so cool. So we only get daytime whenever our side of the Earth is facing the sun. And the other side, while we have daytime, the other side is snoozing. They're sleeping because it's nighttime for them. It says the sun is shining on this part of Earth. It is daytime here. The sun is not shining on this part of Earth. It is nighttime here. It's kind of cool. And it also told me that it takes 1 day for Earth to turn in a full circle. 1 whole day. How many hours is 1 full day? 24 hours, yes. So it takes this little guy 24 hours to go in a complete circle. Imagine having to rotate and you take 24 hours to go from front all the way back again to the front. That's exactly how long it takes Mr. Earth here to rotate 1 full rotation. This page here is called night, day, night, day. That kind of sounds like a pattern, doesn't it? Each day has a nighttime and a daytime. Night follows day and day follows night. When something repeats, there is a pattern. How many times does the night and day pattern repeat in a week? That's pretty cool. During the day, you can see the sun in the sky. And at night, you can see the moon in the sky. During the day, there is a lot of light. The sun lights the earth. At night, the sun does not light the earth. You have to turn on your lights so you can see. And that is true. So this book taught us so far, just this page, taught us that it takes a whole 24 hours for Mr. Earth to rotate to make day and night. So there are 24 hours in a day. That's why we call it a day, because it takes the Earth a whole day to turn around. We also learned what a pattern is, what the definition of a pattern is. So I'm going to go ahead and write this down under this question, what is a pattern? It's something that repeats, just so that we remember. Something that repeats. So of course, we know already that day and night is a pattern because we get it and we know the order of it. After day comes night. After night comes day. And it's going to keep going on and on and on. So that's kind of cool. So I actually, before we read another page from this awesome book, I actually want to show you with blocks here how we can see the pattern of day and night. So we know that in one day there are 24 hours. The book also taught us that half of that day is going to be daytime and half of that day is going to be nighttime. So I'm gonna use these cubes and I'm gonna show you what it would look like. We're gonna make a pattern of what it would look like for day and night to be a pattern, okay? So we have, I know that 24, if we split that in half, it's gonna be 12 and 12. So we're gonna do 12 hours of daytime. So that's what these yellow cubes are. So each cube equals an hour, okay? So let's do that really quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. So right here is half of a day. And after half of a day, we are going to get nighttime because the earth is turning away from the sun. So we are going to have nighttime. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay. Whoops. Oh my goodness, that flew off. Alrighty, so here is one full day. So this is one day. So we wake up, we enjoy our day, and then the sun sets, and then we go to bed, and then what happens next? Daytime again. So then we're gonna have 12 hours of daytime again, and then, ooh, this is getting really long, isn't it? And then we're gonna have 12 hours of nighttime. Whoop. Ooh, look at this long tower. Do you guys see a pattern? Oh my goodness! Before it broke, did you guys see a pattern in that? That's kind of cool how the earth is already giving us a pattern. It's making a pattern on its own. Let's see if we can fix this guy. Okay, let's see if I can hold it up. Here we go. We have 12 yellow, 12 black, 12 yellow, 12 black. What would go next? 12 more yellow to make another day. So right there, we already know that Earth is giving us a pattern already. But my question now is, well, I feel like sometimes in the summertime, the sun is out a lot longer than in the wintertime. Do you guys notice that? Like, we get to play outside a lot longer in the summertime than in the wintertime because the sun just sets so much quicker. So does that still mean that we get 12 sunlight hours and 12 nighttime hours in a day all year round? Well, that's where we have to look into this book to find out. So let's find out really quick. Now, I mentioned the earth is tilted, remember? Let's see if that has anything to do with it. So in the table of contents, we have right here, I found an awesome title. It says, A Tilted Planet. That's exactly what our planet is. It's tilted. Let's find out why it's tilted and if that has anything to do with the different sunlight and nighttime hours in a day, depending on the season. So let's go to page 14. Here it is. Okay. Earth is tilted. When something is tilted, it is not straight up and down. So again, imagine kind of bending over like this and walking like this all day. You'll just be tilted all day. That's exactly what the earth is doing. As Earth travels around the sun, different parts of Earth are tilted toward the sun at different times. The tilt of the Earth causes the seasons to change. Oh, that's so cool. That's so neat. So I know we talked earlier about how the Earth rotates to give us day and night. Well, as it's rotating to make day and night, it's also revolving. So it's going around two different ways. It's going like this. That would make me so dizzy, right? So not only is it giving us day and night, it's also giving us years. And throughout those years, it's giving us seasons. Let's read more about this awesome tilted Earth. Okay. It takes 365 days for Earth to travel once around the sun. So one full revolution is 365 rotations. So this thing has to turn around or rotate like this 365 times before it goes completely in a full circle around the sun. Oh my goodness. So here is kind of where the Earth is tilted. And then you see that it's not only revolving, but it's also rotating. So two R words. More or less light and heat. Let's read about that. Each season gets a different amount of sunlight. Each season also gets a different amount of heat from the sun. The light and heat from the sun change the temperatures of the seasons. This diagram shows the seasons in North America. So we live in North America, which is the top part of the Earth. So if you kind of like draw an imaginary line right here, we're on the very top. So whenever the sun or the Earth is tilted and the sun, imagine the sun like right here, the top part of Earth is a lot closer to the sun than the bottom part of the Earth. So that's when we get those summer seasons. But as it is revolving and now the Earth is here and the sun is right here, the top part of the Earth, even if it's facing this way where the sun is, the top part of the Earth is still kind of farther away because now the bottom half is kind of pointing towards the sun. So that's why we get winter, because the top part of the world is kind of farther away from the sun than the bottom part of the world is. So it's kind of like opposite. When we get winter, they get summer. When we get summer, they get winter, because it all depends on that Earth and how close the top part of the Earth is tilting towards the Earth or the sun. So this right here kind of explains it. So it says that for autumn, which is this one right here, you see that the tilt is kind of like going, like here's the top and then there's the bottom. It's kind of tilted like that. It says, in autumn, North America starts tilting away from the sun. The days are shorter and colder. And then after autumn, we know is winter. And this is how the Earth is revolving around the sun. So after autumn is winter. And now notice that this is the top part and the bottom part is actually leaning closer to the sun than the top part is, because the tilt is going away from the sun. It says in winter, North America is tilted away from the sun. It is cold outside and the days are even shorter. And then after winter is spring. So in spring, North America begins to tilt toward the sun. The days get longer and the weather gets warmer. And of course, my favorite, summer. In summer, the North America is tilted toward the sun. There is a lot of sunlight. Daytime is much longer than nighttime. So again, notice here, it is facing closer to the sun. Look how the tilt now is closer to the sun. So that's when we get those awesome warm summer days. So if we didn't have that tilt from the Earth, then we wouldn't get seasons at all. The weather would just be the same all year round. And we also wouldn't get different daylight and sunlight hours. Every single day would look just like this. Night, day, 12 and 12. Every time. But thankfully, because of the Earth's tilt, we get different hours. We're going to take a look at those hours and which months we get the most sunlight hours and which months we get the least sunlight hours and maybe the most nighttime hours. Okay? So we're going to take a look at a graph, and I'm also going to show you some examples using more of these cubes. Let's get started. Okay, so right here I have a graph that we're going to go ahead and work on really quickly that shows how many daylight hours each month mostly gets. Okay, so I have a yellow marker. I'm just going to kind of color in bar graphs for each month. The first one that we have here is December, which is a winter month, and that's why you see that November, December, and January are kind of bluish because that's our winter months. And in December, we get about 9 daylight hours every day in December. So let's go ahead and we're just going to color all the way to 9. And then in January, we get about 10. So a little bit more, but still not quite. And notice that we still have 24 hours in the day, but if we don't have those daylight hours, if it's not yellow, then the rest of them are going to be nighttime hours. So look to see how many nighttime hours we get in December. A lot, right? And same thing with January. We only get 10 hours of daylight, so that pretty much gives us 14 hours of nighttime. And then in February, we get 11 hours of daylight. And then March, which is my birthday, and also you see that they're yellow, so that's kind of the spring months. That is going to be 12 hours. So my birthday month has 12 hours. So mine's kind of in the middle. I get 12 hours of sunlight and 12 hours of nighttime because, again, it still equals 24. April, which is also in spring still, we get a little bit more because, again, the earth is getting closer, or the tilt is getting closer to the sun, so it's going to start becoming summertime, which is in May, and that's when we start getting a lot more of those sunlight hours. So I'm already noticing a pattern here. I'm seeing another pattern. So June is going to be 15. Kind of looks like stairs, doesn't it? Yeah. And then you would think that the next one would be 16, but that's when it starts to slowly go down. So in July, we get 13 because now the Earth's tilt, where we're at, is starting to revolve in a spot where the tilt is starting to face away from the sun. So we get 14, and then we get 13, and it's just going back down. So now we're getting those fall seasons. So August is kind of around fall time, and then 12 for September, 11 for October, and then the month that we're in right now, we're mostly seeing about 10 hours of sunlight, and the rest of them are nighttime. So you're probably noticing right now that the sun is probably setting and the sky is getting a lot darker now than maybe it was at the beginning of the school year or even in the summertime, right? And it's because of the Earth's tilt and where it's revolving around the sun. It's kind of cool. So I also have here some of those cubes. So I kind of mentioned that my birthday month is in March, and it's right in the middle. I have 12 and 12. So I have 12 on my birthday month. I have 12 daylight hours and 12 nighttime hours. But right now we're in November, which is getting super cold, and it's starting to get wintry, right? So we actually are getting less daylight hours. We are getting 10 daylight hours and 14 nighttime hours. But notice these two are still equal because they both have 24 hours. But if you look at the daylight ones, see how March, this one here is the March one, has more daylight hours than November, but there's still 24 hours because every day always has 24 hours, but the amount of time that the sun is out is always going to be different because of the Earth's tilt, and we are revolving around the sun. So I want you to kind of take a look at this graph, and which one is your birthday month? Where does your birthday fall in? What month? And then I want you to think, well, how many daylight hours am I probably gonna get on my next birthday? And maybe every birthday after that. I want to challenge you to maybe create a pattern. You can draw it on a piece of paper. You can build it with some type of blocks if you have them, but find out how many daylight and nighttime hours you get on your birthday month. And I want you to explore with those by making a pattern, since now we know a pattern is something that repeats. So every year in March, I'm always probably going to get 12 hours of daylight and 12 hours of nighttime. I hope you learned so much about the world around you, and I hope you learned how now we get seasons, and maybe you can go tell a grown-up the amazing, awesome way we get seasons. Again, it's because of the Earth's tilt, and it revolves around that big sun that we have that gives us that bright sunlight and the nice warm weather. So I had so much fun exploring more with you, and I hope you had so much fun also. I will see you next time. Bye.
Teaching in Room 9 is made possible with support of Bank of America, Dana Brown Charitable Trust, Emerson, and viewers like you.